Hey everyone, Tim from Toolpath here with another Geek Tips video. Are you still deburring your parts with the whirly tool like an uncivilized savage? I've definitely overthought some chamfers in my day. So let's stick around because today we're going to go full geek on chamfers. How I program them, how to handle different features, and basically just a bunch of geek tips to make your parts shine. Now that I've got you hooked on that, why are we making these videos? One, I'm just trying to give back to the community that I love so much. And two, as Toolpath continues to deliver more and more on making you more productive, I think there's always a space to get deep into the geeky details of a toolpath. And that's what I'm here today to do. Help you kind of leverage what Toolpath is doing with automating a lot of your chamfers. But I think for a while, there'll be some really geeky under chamfers, 3D chamfers, things like that I think we can improve on. My hope is that your parts come off the machine done and ready to ship. So check out our other geek videos. Hopefully it all ties together to making machining more fun and productive for you. Like, subscribe, hit the notifications button. Got a topic you want to geek out on? Drop a comment in the comments. I love reading them, and I keep adding to my list of videos to make. Sorry we took some time off for the holidays and to get over a little bug. But for now, let's get to work and get into some chamfers. All right, so here's the parts we're going to work on today for our chamfers. Some really good examples here of what I would call closed chamfers, just your basic chamfers. I think these are all the same size, but I'll show you a way where how to select these. It doesn't really matter what size the chamfers are. They can be all different sizes. And then we have some variable chamfers that change geometry throughout the closed contour. We have some 3D chamfers, and then we'll modify a part to show you how to machine this if it was like a 3D chamfered edge with no modeled chamfer. And then we'll probably spend most of our time on this here, this kind of under chamfer. Show you a couple different ways to machine that with different tools. And then we'll show you this here, what I would call a open or blind chamfer is usually what I call those. I think I showed you how to do that on a previous video, but I'll go into that a little deeper here. So with that said, let's get to work. We're going to jump over to this part. We're going to make all these available. My buddy Justin is going to make a place to put them, and we'll share the link with Ben, and he'll make sure it's in the description below. So let's get to work. Let's get some easy wins first. So we're going to go to the manufacturing tab. I already have the setup. This I'm not cheating, but this I just define the solid as the stock and the part. So we're just banging on some chamfers. So we want to start by getting our quick wins first. Feel good about ourselves before we get too far. We have two options. I like to use 2D contour for any closed chamfers like this or closed contours. And then I save 2D chamfers pretty much only for this type of feature. A blind chamfer where it's going blind up against an adjacent wall. So let's start with a 2D contour. So let's get started by going in and grabbing our 1/4 inch chamfer mill. I think we have one right here. And this is very simple. I grab the bottom edge. Pretty much most people grab the bottom edge. And I grab all of my closed contour chamfers. So, this would be the edge of the other side. And then let's just hit OK. I would not have done that, but I want to show you what we get with that. So if we go to this view and we come around, let's go over here, go here, go here. All right, this is what I'm getting at. So we get a one-to-one edge with that, and we don't want that. If anything's not perfect, you'll get a funny little edge there. Shouldn't be talking about a simple chamfer that long. So all we have to do is go to the passes tab and give it a tip offset of really should be going as big as possible. So when you get up to the better cutting condition of the tool. So if we go to simulate, go to that point. Now as we kind of push it through the toolpath here, we're way up. The higher you get up here, the better the cutting condition is, because the higher the surface speed, right? The closer you get down to a tip or a sharp tip tool, the closer the surface speed gets to 0. So generally you want to get up as high as you can, somewhere in the middle. Toolpath does a really good job of making these variable, but kind of utilizing the higher edge of the chamfer mill. So that works really good for that. So this was real simple. It probably took too long to explain that. The next thing we want to do is probably talk about blind chamfers. So that's why I use this 2D chamfer tool here. And I would grab that, and honestly, I just hit OK. Now the magic behind that is that I have some really good defaults, and I'll show you those defaults. So let's hit simulate. Let's scrub down here. I think we're gonna just turn off the stock for now. But I like to get this open air here. So as I kind of scrub with my cursor left and right, I've shown this in other videos. It's one of the better tools you should know. Look at that clearance right there. Now we don't know how much that is, but I'll show you where to find that. And then you also have the upper edge of your tool it's 10 thou above, maybe it's 5 thou, but it's 5 or 10 thou above that, and I'll show you where that's being driven from too. But the nice thing is if you do turn on the stock, you can see how close you're getting to that edge. We could flirt with it and get even closer, but a little pro tip is the higher you get to this edge, the closer you get to that edge. So it's pretty basic geometry. That leaves a really nice chamfer there. Maybe hit this with a little fiber brush, a little wire brush or something if you have a little hairy stuff there. This is what we're making here. Made thousands of these things. Actually, I've made hundreds, but a lot of HFOs have made them. We'll make sure you guys have the link if you guys want to make them. All the toolpaths are in this here. So if you go down here, I have a bunch of locked toolpaths. So if you want to see how the key seat cutter and all that works, you can go do that. If you really want, we can dig into those videos. There's a little bit of a tricky key seat cutter move here that we can help you through if anybody needs that. So that is a 2D chamfer tool that sneaks you within 2 thou of this wall and gets really close there. So we've talked about how to do that in the past. I'll show it one more time. If we go to Passes tab, the magic is in an expression that I have saved in the chamfer tip offset. If you watch this 80 thou, if I change this chamfer to 20 thou, that changes to 70. If I change it to 40 thou, that changes to 50. We'll leave it at 10, and let's understand how we got to 80 thou. So if we hit expression here, this might be a little, let's make it long form. It's pretty simple. It's taking the tool diameter, it's dividing that by 2. So that's half the tool. So for us, it's 125 thou. It's taking the tool tip diameter, the little flat at the end, and it's dividing that by 2. And what that's really getting is the cutting edge of the tool, right? From the flat up to the tip there. And then what it's doing is it's subtracting the chamfer width. Don't worry about this. I'll explain this in a second. Because in that cutting area, you also need to account for the chamfer width, right? And then the next thing it does is this 5 thou. That's what I call like your top clearance or whatever we want to call that. But that's where the top cutting edge is 5 thou above that flat surface. That's where this comes from. If you're comfortable that your tool's accurate, if you're comfortable that surface is within a couple thou where it's supposed to be in the perfect model, 5 thou works good for me. Maybe you want to make that 7, 8, 9, 10, something like that. But this is a really good expression that I've been using for years, basically since this magic 2D chamfer tool came out. And then once you type all that in here, you're just going to go to these 3 dots and save as user default. And that's why that toolpath was so easy. I just went 2D chamfer. The last thing I did was chamfer, so that saved that. So there's 1, 2, 3 mouse clicks. Magic. So we have that done. Let's handle these odd chamfers next. So we'll come to 2D contour. Already have the chamfer tool. So we showed you with these chamfers, you grab the edge. So what happens if we grab that, I said bottom edge is what I meant to say over here. So what happens if you grab the bottom edge here, come over here, and give it a, we'll say a 20 thou tip offset. It actually looks like it worked, right? So let's go see what actually happened. So it looks good until you get there. So that violates the model pretty aggressively until it gets to that surface, and then it's happy. So how do we fix that? Well, if you go back and look at this, I programmed this a lot of years ago. If I come in here, you'll see I broke it into 2 different chamfers. To be honest, maybe I would do that again. Maybe I wouldn't. And then I just broke it into 2 different chamfers that way. Treated them like 2 open kind of chamfers, which is easy enough to do. You can go to 2D contour. You can click here. You could click it again. You could decide open chain, and then you can come around, actually kind of lead it way that way, and then you can wrap it here and then there. Hit OK, and now we would come here. Give it some, tip offset. So that will chamfer just that edge, right? But then we'll have to flirt with, not flirt with, but I turn the stock off because I left that there. But you'll see it's giving me a good chamfer on that edge. But then you'll have to play with how it leads off and how that works with that. I wouldn't do that. If you get chamfers like this, you can just grab the top edge, and then let's say here we'll give it a 20 thou tip offset. Now I would actually make that bigger because I know what's going to happen, but I wanted to show you. Let's go get rid of some of this garbage first so our stock simulation works good. Oh, I think I just got rid of the one I wanted to keep. No problem. So I'll grab this. We're going to give it a 20 thou tip offset. Looks like a good toolpath. We'll do simulate, turn stock on. And here's the problem, is it's not violating our model at least, but it also is not going to chamfer that bottom edge. So we need to make that bigger. Doing the quick math, this is 60, it's a 1/4 inch. I just do this. We have a 1/4 inch 4-flute chamfer mill with a 60 thou tip offset, or tip diameter. So that's 125 is the radius, right? Minus the radial part of the tip. So it's 125 minus 30, you have 95, yeah, 95. So I could give it a 95 thou tip offset, and that top edge would be equal to that edge. So let's give it a 75 thou. No, not negative. I'm going to give it a 75 thou. This is my extracurricular activity. So these are kind of evening things for me. So my brain's already fried. Sorry about the mess ups. All right. So now we're happy. Now we're cooking. This bottom edge is below that. The top edge is below that. I might flirt with that a little bit more and bring it down, but you get the idea. So that's how I'd handle that. I want to make sure to leave time for probably the biggest chunk of time we're going to spend on is this under chamfer here. So first way to do that would be with a dovetail. And Toolpath is working on dovetail under chamfering. And that's probably the first thing you'll see for under chamfering with dovetails in Toolpath. And then, so let's go grab a dovetail cutter. Yeah, so here's our dovetail cutter. And so you just grab here. Okay. If you've watched any of my other videos, I sure am tempted to just hit OK and see what we get. Go fix what we don't like. So let's simulate that. I'll stay consistent at least. I don't do a lot of things good, but I'm mostly consistent. So what's happening here? We're going online with that geometry selected. This would be a really good example of a situation where I would do inspect, I would do a section analysis, and I would split that sucker right there, because that will make our simulation visualizing what's actually happening way easier. If I come in here, you can see what's happening, right? So we're not actually chamfering. We might actually get rid of a burr for all we know. If we had a crappy burr there, we might get rid of it, but we're still going to leave a sharp edge. So how do we fix that? The tool needs to come down and in. I do that with the stock to leave area in the passes tab. So if we go to edit, come down to stock to leave, we could go in 10 thou, -10, and we go down 10 thou. Now what do we get? I imagine some of you are screaming at the screen right now, and others are hopefully following and just listening. But scream at the screen is a valid reaction, because it's a 45-degree tool. You come down 10 thou and in 10 thou, you're still just touching it. But you're getting rid of a burr, not getting rid of the sharp edge. So what we need to do is come down 10 thou and probably in 20, right? Luckily, it's a 45-degree tool, so the trig is very simple. So go to edit, go back to passes, and then I'll just do -20. The axial is connected, so we'll break that and go -10. And that'll get us the chamfer we want. So we go there, go to front view, and let's advance this till we get the chamfer we want, right? Yeah, so that's good. That's exactly what I wanted. I wanted this 10 thou under it, and I wanted a 10 thou chamfer. Now, how does that look? Oh, so I just showed a problem there. On the lead out, we had a pretty good gouge. Maybe you don't care. My hope is that I'm showing you stuff that will let your parts come off the machine better, more consistent, less carpal tunnel from using these stupid whirly tools. A little shout out to Chris for sending me this cute little guy. Vargas made this cute little guy. I saw it at my buddy Carl's shop, and I got a kick out of it. So my buddy Chris hooked me up. MSC, if anybody wants them. I actually use it quite a bit, rarely on machine parts, interestingly enough. But my idea is that you're not getting carpal tunnel. Your parts are super consistent. You're not scrapping parts by hand. So anyways, let's get back to this. How do we avoid that gouge? Well, old school, before you had this automatic avoidance kind of 2D chamfer, or this other tool that I'm going to talk about in a second, we had to do this. We had to, and we still have to do it on these under chamfers. We had to come into the geometry tab. Well, first thing we want to do actually is get a good lead out. So you typically don't want to do a radius lead out. So we're going to turn that off. Turn it off, meaning zeroed out. And we're going to turn on perpendicular lead outs. That's really going to fix our problem, but you can see, at least we know we don't have to worry about this other stuff. And the other thing we need to do is trim this backwards until it's not gouging that wall. So we're going to edit. And a lot of people don't know about this. There used to be actually tangential extensions in the geometry tab. So you can do a negative tangential extension and pull the toolpath backwards. But the way you do that now is you either double click here or you right click and edit. And that functionality is opened up here. So if I open this up, it'll say start extension length or end extension length. And those could be negative values, which is exactly what we're doing here. So unfortunately, there's a couple ways. You can sketch it out. You can do a bunch of sketches and figure out where you need to do. You can even drive it on a sketch. That's old school. I used to have to do that. I've got hundreds and hundreds of hours into doing these types of chamfers. But I also have a lot of people that appreciated my my final finished parts. So cheers to that. Anyways, let's do a -50 thou. Usually you can get it within a few guesses, to be honest. As much as I hate guessing, Then you do simulate. I usually just kind of go straight to that point right there. I'm still gouging. So we had it at 50. We can go to some bigger value. I'm going to guess, I don't know, let's guess at like 145,000. Oops, let's type that in properly. Negative 145,000. Let's see what that gets us. There we go. So we're missing the wall. That's a little too much, to be honest. That's too much. I would flirt with it back and forth. I'll spare you guys. We can still squeeze in there a little bit more. The closer you get to this tip, and honestly, we might even want to use a smaller tool. I think this is 130 thou radius here. If we use a smaller diameter tool, we can sneak closer to that edge. Kind of go back and forth. Did I get lucky with the 145 thou? No, I did a dry run on this before to make sure I wasn't going to embarrass myself in front of you guys too much. And I took some notes. But that's basically how you handle that. Used to be if you want to do a chamfer like this, you would have to do that negative tangential extension and keep kind of going back and forth until you didn't collide into that wall. I suspect, now I'm not giving you any futures, but I suspect my buddy Justin and our development team will watch this video and hopefully get inspired to solve these problems. That's the kind of stuff we're really looking to do at Toolpath is that's like mundane, hard work. And we want to let you use your brain to do more creative things, solve tolerance problems, solve fixturing problems, and things like that. This stuff, computers actually do a really good job of this stuff. But for now, that's how you do it. I'm telling you 1,000 times over, I would much rather spend an extra 2 or 3 minutes doing this, and then maybe even coming here, store as template, and say Dovetail under chamfer. I'm messing up on my other screen. I had to go pick my my cloud library. Hit save. Okay. So now what I could do is here I could say create from template. I'll go select template. We can do a whole thing on just that. So dovetail under chamfer, select. I think I wrote over my buddy's chamfer. Do this, turn the analysis off, and then all I have to do now is repick that geometry, and then we're good. That's probably a good reason to use, probably a pretty good reason to use that template workflow. So another more common, I call it a side chamfer tool. It's at least what I use and a lot of my friends use, is if I go to Harvey, it's like a double angled chamfer tool. If I go to products, go to double angle shank cutters, that's kind of a weird name. This one, I use a lot of these. I have them out in my garage for my haws out there. I would search for 90, maybe 250. We want. We have to decide what we want now. Let's just use this 1 inch here. Okay, so here's how you have to do this. Unfortunately, Fusion doesn't have a way to define these tools yet, and we're exploring this with Toolpath. How do we want to use tools like this? But for now, you're going to download the DXF, and you're going to learn about how to. You're going to learn how to create a form tool. This is pretty important, so pay attention. Get your pencils out. Okay, so I like to go to a new design and then do an insert DXF. You can pick any plane you want to put it on. I have a habit of putting it on the top plane. And then you go find that DXF, which is in my downloads folder, and hit OK. And there's your DXF. Now what the heck do we do with this thing, right? So we're going to right click and edit this sketch. And we need a center line for that sketch. So I'll just create a center line. If you guys didn't know that trick, by the way, I'm just hitting S on my keyboard. I'm actually hitting S on my Space Pilot. I like them. That's how I also get these kind of smoother moves. I'm not here selling space pilots, but do a line, do it from here to here. Undefined blue sketches give me anxiety, but I'll ignore it for now. And then one thing I like to do is always get this measurement here. No, this measurement here. So 62.5 thou, 16th of an inch. It's not the dumbest thing you could do to get this dimension here either. Well, I already knew it because we searched for that 1/4 inch tool, right? But so you need double this because this diameter is what we're going to drive the tool off of. And then the other thing we're going to do is we're going to put a sketch point. I'll just put it down here, and then we're going to constrain it from here to here, and then we're going to constrain it from there to there. So horizontal and vertical to basically the convergent point or the intersection point of this. That's going to be called later. We're going to use that as a control point. Okay, so we're going to finish that sketch. And then we're going to go to the manufacturing space. We're going to go to manage form tool. So we're going to pick a tool profile. We're going to pick a tool axis. That's the center line of the tool. We want to make sure our arrow is pointing towards the business end, the parts, right? So we'll flip that axis, make sure our red arrow is pointing towards what we want to cut. And then the compensation point, that's this point right here. So if I do a probe in my machine, or if I'm using wear compensation, it's actually going to be driving it from this point. That's the Z bottom, and that's the Z top. Now you could drive it up there. There's lots of reasons you would do that. We're not going to talk about that now. Generally, it's going to be for like a port tool, something like that, where you have like a more critical dimension that you want to drive it off of. You know, a comparator, optical comparator, or something that you're setting the tools with. For now, we're going to put it right there. Hit OK, and it appears that nothing happened. Form tools, I'll give them some grace. I was one of the product managers for the tool library a long time ago for Fusion. They had some resource shuffling, and Form Tools was basically made as a minimum viable product, and then it was finished later. So what happened is we just had that untitled document, and it just created a form tool. So I think I did it without talking, but what I did is I opened up the tool library, and then I went to the, untitled, and we have our form tool. So now what I would do is I would copy it from here. I'd right click and copy. I'd go put it in a library. We'll skip that for now, but I'd go put it in a library. I'd call this 1/4 inch side chamfer, and then what I do is I do 0.0625 tip height. Since I've got your attention, it's not bad hygiene to put in the vendor. The product ID would be here, 19503, and then to be honest, I do love being able to do this. I copy this and I put it here. I don't know how crappy that's going to be for your video, but hopefully that comes out. So then the only thing I do here is I don't actually have a flute length of the whole tool, so I would do a flute length of should be 0.125. Yeah, so now I can cut that area. Length below holder, let's just make 1 inch, and then I go pick a holder. I got a lot of these Haas Cat 40 ER25s out in my shop, so I'll use one of those. No, let's go back to cutter. That's going to drive me nuts. So let's do, I don't know, 125 thou. Yeah, that's about how I would have it set up, right? I would measure it and then set it up properly, just for the record. So then cutting data, I'm going to run this thing at 12,000 RPM. I realized I didn't put a cutter, so we're gonna have 4 flutes on that. I'm gonna do a chip load of 1/4 thou per tooth. I'm gonna haul butt around that thing. Maybe I'll do 3. I would do 4 just for the record. Some of you guys like CJ get scared when they see that. Okay, so that's good. So how do we use that tool? So I put that node in there. I'll show you why I put that node in there. So let's get rid of this dovetail so our simulation works good. I'd come over here. Let's just go to Untitled, grab this tool. I would have stored that in one of my tool libraries, I mean. That flute length is concerning to me, but whatever. See over here in the note where it says 62.5 thou top height? I think I actually grabbed the wrong tool, whatever. Go to geometry, pick here. And then it's the same. Oh, this is a similar thing, right? The bottom of the tool ends up here. That's not what we want. We want this part of the tool to be down there. So what we have to do is go to the passes tab, stock to leave. Let's zero out radial for now, and then do a negative 62.5 thou. And then turn the section analysis on, simulate. And then when we run through, you'll see here, we basically get a point-to-point like we had with that dovetail, right? It looks like I didn't delete that dovetail. Okay. So anyways, we had a point-to-point. So we got to do the same thing we did with the dovetail tool. But we have an additional this, right? So we're going to do a negative 20 thou here. And I'm going to do an additional negative here. Type in inches to make sure that you're using inches. I say that because if you type in just a number, the kernel's metric, so typing in inches will ensure that you get the desired result. So that should get us what we had in that last. Let's simulate this in that last toolpath. Yeah. Just like that. Now, the nice thing here is you can use this tool to chamfer on the bottom. You can use it to under chamfer. You can chamfer here. You can just use it all over the place. A lot of people like dovetail cutters too. My experience is that this edge is tougher. So I've cut a lot of kind of harder materials, and these tend to survive those cuts better. So this is a more general tool. Instead of having a dovetail for aluminum and this, that works really good just to use these. The only thing I would say there, some people like to under chamfer their first op. And then that way when they flip it over, they basically face it and they're done. And then you don't have any misalignment issues if for some reason that was a concern. That might be better with a dovetail cutter on aluminum, unless you want to hold on to more material. If you have more material to clear your fixtures, I still use these. They're great. I think I covered that. I think that's about as deep as we need to go there. Feel free to comment if you feel like I lost you. But I want to move on. I don't have a time tracker. I should have started a time tracker. But I want to move on to these 3D chamfers, and then I'll wrap it up with this chamfer here. So 3D chamfers. If you go back and watch probably 3D containment toolpath video, Ben maybe put a link there or wherever. I'm sure I covered the chamfers, but let's do it one more time. So we're going to use a ball mill for modeled chamfers, 3D modeled chamfers like this. I really like. This thing's been through the dishwasher 100 times. But I just really like this, these nice 3D chamfers are a really good feature on a part. Adds just a really nice touch to it. I'll start off with scallop because it's easy. Everybody starts off with scallop. Go to selection. If this is losing you, go back and watch that containment video that Ben linked to. That's probably worth. I can't talk about selections enough. So the selection manager, I clicked this geometry, didn't get exactly what I wanted, so I just clicked it again. The selection manager popped up. I went ahead of where it made the wrong turn. Said, no, go this way. I just confirmed that it went where I wanted there, and it didn't. So I'm going clockwise around it. We're made the wrong turn here. I go ahead of it, click there, hit OK. Now that is the geometry we wanted. If you watched a previous video, you don't have to watch me go through all these settings, but I would turn on contact point boundary. I would zero this out. Man, we'll play with this in a minute. I can't hit that home enough. Passes, let's make this something small. And then when you're doing segment geometry like this, it's really good to have a small tolerance. So my default on these little segment geometries is go like 1/10 tolerance. Let's see what we get. Looks like I grabbed the wrong tool. I thought I grabbed the ball mill. Apparently I didn't. All right, it's pretty messy. Pretty messy. So let's go back to edit. And if you watch that containment videos, first thing I'm going to do here is type in negative tolerance. See what that does for us. Cleaned it up a lot, didn't it? We still have some noise out here, and it's just kind of a function of the geometry and the toolpath. So I can do a lot of different things. I can just start coming here, go to create a derived operation, and just start trying other toolpaths. Maybe I would do steep and shallow. I actually know which one I would do, but maybe I'd do steep and shallow, and we can get maybe a cleaner toolpath by limiting this to shallow only. And so we have the access to only the steep and shallow scallop that comes from the Delcam kernel. I don't know, it seems like not a bad place to start. It's a little better. It doesn't quite go up and catch this feathery stuff though. So really what I would do is I really like this geodesic toolpath that comes from our friends at ModuleWorks. Shout out to those guys. They've really changed the industry since I've been here. Not here, but since I've been in the industry. It's been fun to watch how much they've really changed the industry with their pretty rad toolpaths. And it's fun fact, it's Toolpath is partnered to have a strategic partnership with ModuleWorks, and we leverage their toolpaths kind of in the background. So hopefully you'll see some more interesting things with them kind of surface along the months and years. So geodesic, go to geometry. It because we did the derived toolpath that came over with the geometry selection. It does want to drive surfaces though, so let's give it what it wants. If you know me, you know I like to hit OK and see what happens. Holy smokes, that looks good. That is a good looking toolpath. Maybe it's way too many passes for just a chamfer. So we have options there. Maybe we can limit the number of step overs and go 2. Maybe let this be 10, something like that. It's still a cusp height of 2/10. Not 3 thou, but 3/10. Try that. And I limited the number of step overs, right? So that's pretty important. So I give it a couple step overs on each side of the center. I would probably run that. I probably would. Maybe I'll give it a 1 thou step over, 1 thou cusp height. See what that gets us. And then we can even do, if you're just trying to micromanage it for time, cycle time, we can go from 8 seconds to this. That's just 1. That's 2 seconds. I personally would probably want, with that big of a chamfer, I would probably have it 2. So I'd probably let it do 8 seconds on each side. Well, it really depends on the quantity I'm doing, right? But that would look really, really good if I do a simulation. Come all the way out to this tip here. You can see it's really coming out. And it's hitting this hole, it's feathering that edge in there. It's just a really nice setup. Geodesic has become a lot of people's favorite toolpath. Maybe we'll do some 5-axis stuff. I did this part with geodesic. There's some really cool stuff with that. So we'll see how that goes. Shout out to the ModuleWorks boys. That's a good toolpath. That's a really good toolpath. And another shout out to our ModuleWorks friends. The next toolpath I'm going to show you is for 3D chamfers really any chamfer hard edge that you want to just deburr with a ball mill. So you can you can do this in 3, 4, 5 axis, not head geodesic. Go to 3 axis, go to deburr. You have your multi-axis options here. And what happens if we just hit OK? We got a deburred part. 1, we already have the ball mill selected, so like 1, let's delete that. Let's delete that. So we have 1 click, 2 clicks, we already have the tool picked, 3 mouse clicks, 4 because I missed it the first time, 3 or 4 mouse clicks, 4 if you miss the button. You're probably saying, what the heck's happening? Well, it's picking up hard edges, this hard edge, that hard edge. So we have a couple ways to manage that. The way I would manage it, I'll show you first. Let's duplicate this so I can show you a couple ways. One, I didn't practice, so we'll see how we do. We'll duplicate it, and then we'll come back and edit this. The way I would actually do it is I would come to edges to deburr, and I would do selection, and I would just pick this edge. I would click it again to turn on the selection manager. I'd make sure I had open chain. I'd pick the last segment in that chain, and then I would hit OK. And I would get a really, really, really nice toolpath that deburrs that in 2 seconds. Without gouging the side of my thing, without cutting my wrist, without getting carpal tunnel. I need to save my wrists for my dirt biking, and I'd be happy. So let's dig into that real quick, because that is a pretty fat chamfer. If we were looking for something more like that, that's probably a 30 thou chamfer. We can come to the passes tab. We can tell we wanted a 30 thou chamfer, and then we can do multiple passes. Maybe we want 3 passes. Probably do something like that. Holy smokes, that is a really nice looking toolpath. Really nice looking toolpath. If we wanted to get back into that, I would probably tell it to, I thought there was a both ways option. Maybe I was wrong. Okay, so let's get into this one. There's some other controls that I haven't looked at in a long time, to be honest. So if we go here, it's this minimum edge angle. So what happens if we do, we're going for 90, right? It's been a while since I played with this. So what we're really looking to do is hit everything, minimum edge angle, let's say 50 degrees. What happens if we do 50 degrees? Because I think that gets rid of, okay, it gets into some of this weird stuff. But I think my hope was that it would just get rid of the 45s, right? But you can control it with a minimum angle. I don't use that almost ever. So that's why I was tried it on live TV, right? Yeah, so you'd get this and you'd get that, which is pretty good. It actually looks like it's missing some of this. So that's kind of the reason. You see how this goes out there really nice? If you just have a handful of chamfers, you can go grab it. Just go grab the specific geometry you want to do. So that's it, folks. Do us a favor. Go check out what Toolpath is doing. I think we're doing some really cool stuff. A lot of this work should already be done by Toolpath if you're using the cam automation. If you're looking to help yourself estimate parts better, quicker, faster, more accurate without missing features, we do a really good job at that. It's a free trial. You have nothing to lose. So go check out toolpath.com, do a free trial. That kind of makes it easier for me to justify doing these videos. Give us feedback, just like in this video here. If you want to see something, give us some feedback. A lot of these chamfers would already be handled by Toolpath. I went a little deeper into some of the geekier stuff because I think right now and for the foreseeable future, I want people to understand the deep knowledge of toolpaths. So with that, subscribe, do all that geek YouTube stuff. Let us know what you want to see next. We appreciate your time, and go make some rad parts. Cheers.